Hello, geometry student, and welcome to the tangent of a circle. In this lesson, you're going to be provided with problems where you will have to use what's called the tangent of a circle. And by the way, as a punchline, what is a tangent? Oh, that's just a guy that sunbathes at the beach. Okay, but anyway, no, we're talking about the tangent of a circle. Okay, and so let me show you how what a tangent of a circle is. So basically, a tangent of a circle um, touches a circle at one point. Okay, it touches at one point. So this line right here, which is line L, and I know this doesn't look like a circle because I kind of inverted this slide a little bit, but this line right here, line L, okay, which passes through T right here, represents the tangent because it touches the circle exactly once. Okay, so let's remember that. So let's, in fact, let's go and write that down. So remember, a tangent is a line or a line segment that touches a circle exactly once. Okay, it touches it exactly once. Okay, so that's what a tangent is. Some of y'all may be aware of that already, but I just want to make sure everybody's clear about that. Okay, and so it touches it exactly once. Okay, it does not go through the circle at all, it just hits it exactly once. But the majority of the problems that we'll be working with today is the fact that with this situation, that a tangent is actually perpendicular to the radius of a circle. So if you draw a radius of a circle, then it's going to be perpendicular to it. Okay, it's going to be perpendicular to that tangent. Okay, so um, and so what we have to do is we have to use that method or use this situation to help us solve some problems. Okay, all right. So this is our key thing throughout this lesson. So let's go ahead and start doing some problems. All right. So on this first question here is asking us to find the value of x. Okay, find the value of x. And so with this problem, what we'll do is we are assuming that BC, the line segment BC, is going to intersect the circle exactly one time. So I'm going to um, do that at this time. So let me show you that BC, this segment BC is going right here to this circle and see it's hitting it right there. Okay. And so since it's hitting right there, that means that it's a tangent. And since A to C is a radius, okay, because this is circle A, okay, that means that the two segments right here form a right angle. Okay, so it forms right angle. So BC is a tangent. So I'm going to go ahead and write that down here. So line segment BC is a tangent, and AC is a radius. And so since it's a tangent and a radius, they must intersect at a um, perpendicularly. So therefore, that's the truth. So of course, what has happened here is we have a right triangle. Okay, if you notice, we have a right triangle that has been formed. AC is part of it, BC is the other part, and then A to B, okay, is the other part. So this is basically a right triangle, which of course means that we must use the Pythagorean theorem. I mean, I told you the Pythagorean theorem will never go away. So we have to use it for this particular problem. And so as maybe you should know, the Pythagorean theorem, of course, is going to be a squared. Let me get the pen here. A squared plus b squared equals c squared. And so in this particular case, the hypotenuse is AB. So I'm going to replace the C with AB. And then AC is a leg. So I'll just put that right here. And then um, B is the other leg, which is BC. So there's my segments. All right, so now all I have to do is figure out what everything is. So I'm just going to plug in everything that I know. So I'm going to have AC, which is x. So it's going to be x squared plus BC, which is going to be 14. So 14 squared and then AB, which is 17, so it'd be 17 squared. Okay, so x squared plus 14 squared equals 17 squared. All right, so now we just need to calculate what each of these is. So let's start with the fact that we have x squared plus 14 squared. So 14 squared is going to be 196. And then 17 squared, which is going to be 289. And now I'm going to subtract 196 on each side. And I'm going to have x squared equals 289 minus 196, which is going to be 93. Yes, 93. Okay. And that's x squared. And so now all I have to do is, of course, square root both sides because we're trying to get x by itself. So basically that's going to give me x equals the square root of 93. And that would be the exact answer because 93, you could factor it out. You could try to factor it out, but it's okay at this time to go ahead and round it to 2 decimal places. So we're going to go to our calculator. So I'm going to go to the calculator. In fact, let me do that for you. Let me go ahead and share with you the calculator. All right, so I'm going to show you the calculator. So here's the calculator right here. Here's my Desmos. You don't need to have it in degrees mode or anything like that. It doesn't really matter. All you were doing is just going to here and just typing in the square root of 93. And square root of 93, I get about 9.64. The 3 is after that 4, so it does not round. So it'll be about 9.64. So therefore, going back to my paper, I'm going to get about 9.64. And so the value of x is approximately 9.64, which means, of course, that the radius, right, because x was a radius, AC was a radius, that means the radius of this would be 9.64. Okay? All right, and that's how you find the value of x in this particular problem. All right, let's do example number 2. Again, we're trying to find the value of x. So we're going to discover how to figure out what this is. So as I look here, I see that QS is a segment that touches a circle exactly once. I also see that Q to R is going to be a radius. So I'm going to highlight that. And so, because R is a center, so Q is on the circle. So therefore, we have to see that these two, or this makes a right angle right here. So there's a right angle, okay? And so once again, we have a triangle, a right triangle. So we're going to use Pythagorean theorem to help us answer this question. So once again, I'm going to set up the problem. Of course, I'm going to make my statements here. I have QS is my tangent, or QS is a tangent. Okay, and RS, good initials. No, not RS, but RQ, excuse me. But RS is still good initials. And RQ is a radius. Okay, and this is for circle R. Okay, all right. Now let's go ahead and like I said, do our Pythagorean theorem. So again, it's going to be a squared plus b squared equals c squared. All right, so now we're going to have a is actually, let's start with c, and c is actually rs. So I'm going to put rs in for c, and then we'll just say a is going to be qr, that's one of the legs, and then b is qx, that's the other leg. Okay, and so now we're going to fill in what we know. So qr, now QR is a radius, right? So if you look very carefully here, if QR is a radius, that means that this right here is a radius. So from here to here is a radius, right? Because it's going from the center to the edge. So therefore, this has to be x as well, okay? So therefore, I'm going to put x as my QR, because that's a radius, okay? So it's going to be x squared plus QS. So QS is right here. So that's going to be 4. So it's going to be 4 squared. Okay. And then RS is going to be from R to S, which is x plus 2. So it's going to be x plus 2 squared. Okay? All right. So this is our situation. Okay? So now what we're going to do is we're going to work this out. So we have x squared. So let me back this out just a bit, but I'm probably going to end up coming over here. So x squared, of course, is just x squared plus 4 squared. 4 squared is 16. But over here, we have x plus 2 quantity squared. So what that basically means is we have to write this out as x plus 2 and x plus 2. Okay, remember x plus 2 squared means we write it out twice. And so now what we have to do is we have to go back to our algebra. And what we do is we have to distribute x plus 2 to the other x plus 2. Okay, and here's how we do that. What we do is we're going to come down here and write x squared plus 16 equals. And then remember what we'll do is we'll take this x in the first parentheses and multiply it to this x. So that's going to be x times x. That's going to be x squared. Then I'm going to take this x and multiply it to this 2. So x times a positive 2 is going to be plus 2x. Now we're going to come down here and multiply the positive 2 to this x. So now we take care of that, and that's going to be plus 2x. And then finally, we take the positive 2 and multiply it to this positive 2, and we get positive 4. Okay, so remember, that's called, you might have heard it as FOIL. You might have heard it as just distributive property. Okay, mostly it's distributive property. Everything that goes in the first parentheses multiplies everything in the second parentheses. Okay, all right. So now we're going to combine like terms. So I'm actually going to come up here. Yeah, I'm just going to come up here and rewrite this. So I have x squared plus 16, okay, equals. And then over here, I'm going to combine like terms. So I have a 2x and a 2x that I can combine. And so 2x and 2x is 4x. So it's going to be x squared plus 4x plus 4, okay? So now I have an equation that's a little more simplified. So x squared plus 16 equals x squared plus 4x plus 4. And now I'm going to start working on solving for x. Well, if you notice, both of these sides have x squared on them. So what I'm going to do is I'm going to subtract x squared on each side. And when I do that, of course, those are going to cancel out. So I'm going to cancel out both the x squareds. So now all I have left is 16 on this side, and then 4x plus 4 on the other. Okay, and now it's just a simple two-step equation. So we're just going to subtract 4 here on both sides. So it's going to be 16 minus 4, which is going to be 12. And then I'm going to cancel out these 4s. And then I'm going to have 4x still remaining. And then I'm going to divide 4 to each side. And so that's going to be x over here. And then 12 divided by 4 is going to be 3. So therefore, the value of x in this situation is going to be 3. Okay? All right. So the key again is that the tangent is perpendicular to the radius. And then since there was not a letter here, we saw that r to the edge on this side was x, so they had to both be x because every radius is the same for a circle. Okay, it's the same length. Okay, so in this case, again, the radius is going to be 3, and you just had to work through like that to solve the problem. Okay, all right. So there's example number 2. All right, example number 3 is asking us to find the value of x, y. Okay, so that's the segment x, y. Now notice on this particular problem that wx, which is right here and here, is touching this circle one time. Therefore, it's a tangent. This xy is touching the circle one time. So therefore, it's a tangent. Now, so let's go and make that statement. Wx and xy are both tangent to circle z. Okay, they're both tangent to circle z. So when they're both tangent to circle z, then there might be something that happens here. In fact, both of them have the same both have the same endpoint. Okay, they both have the same endpoint. So here is a rule that you need to know. If two tangents, if two tangents share an endpoint, okay, and that's what's happening here. The endpoint here is x. If two tangents share an endpoint, then the two tangents share an endpoint, then the segments are congruent. Okay, they are congruent. They are the same. Okay, all right. So there you go. So that's what you need to remember. So since they both share endpoint x, that means these two segments are going to be the same. So now all we have to do is accept our equation, which in this case is going to be wx equals to xy. Okay, and so now we're just going to solve the problem. So we're going to replace wx with 2y plus 5 and xy with 4y minus 21. And so now we're going to solve for the lowercase y. So we're going to, I want to move the 2y on each side. Okay. So that's going to give me this canceling out. So I'm going to have 5 equals 4y minus 2y is going to be 2y. And then bring down minus 21. And then I'm going to add 21. Let me change colors. Add 21 to both sides. So 5 plus 21 is going to be 26. And then you're going to cancel out these, and you're going to have 2y. Okay. And then you're going to divide both sides by 2. And 26 divided by 2 is going to be 13. So 13 is going to equal to y. So the value of y is 13. Okay. And so now that we know what y is, we're just going to figure out the value of xy, the segment xy. And so to find the value of xy, all we have to do is xy was 4y minus 21. And so now we're just going to do xy equals 4 times 13, which is what y was, minus 21. So it's going to be xy equals 4 times 13, which is going to be 52, minus 21. And so 52 minus 21 is going to be 31. So therefore, the value of xy is 31, which of course means segment wx is also 31. Because again, if two tangents share an endpoint, then those segments have to be congruent to each other. Okay? All right, there's example number 3. And now finally, we have example number 4. And once again, we have, and now we have what's called a circumscribed shape. So now the quadrilateral is circumscribing, is circumscribed with this circle J. Okay, so remember, if it's circumscribed, the circle is inside. Okay, so remember that it's inside the shape. Okay, so inside circle is what I'm trying to say, or circle inside. Okay, so circumscribed means the circle is inscribed. Okay, it's the circle is inside. So what we need to do is we need to figure out the value of x in this situation. And it says the perimeter of this quadrilateral RSTU, so that's the outside shape, is equal to 18 units. So we want to find the value of x. Okay, all right. So this is one of those workaround problems where basically we just understand what is happening with as far as the rules are concerned, then you can do this pretty easily. But it's just a workaround. Now, if you notice here, for example, here's point S. Okay, point S. Point S. If I go from point S to A, okay, that's a tangent. Okay, because it's touching this circle once. It's touching at A. Okay, and then same thing right here. It's touching it right here at D. Okay. Now, by the way, I have not really mentioned this yet in this lesson, but every time a circle or every time a segment touches a point on the circle, like it's on the circle. So basically, you have S to A, and then like here's a B. See, it's touching circle once, and C. So let me let you know, and you need to go and make sure you write this down, is that A, B, C, and D, those points, are what we call points of tangency. Okay, points of tangency. Okay, so a point of tangency is basically where the tangent segment or line intersects the circle. Okay, where it intersects at one time. So all those points are points of tangency. Just like all the other problems that we had where a tangent was hitting that circle, that's the point of tangency. Okay, so points of tangency. Now, let's get back to where we are here. So since S is going to A and S to A is 3, but here S to D is also 3. I mean, S to D is also going to be 3 because S to D and S to A are have the same endpoint. We just shared that. So therefore, S to D has to also equal to 3. Okay? All right? Because S is the common endpoint for that particular circle. Likewise, if you come over here to where R is an endpoint for R to C and R to D. Well, we already know that R to D is 3 units. So therefore, R to C must also be 3 units. Okay, because again, if a tangent goes from, if two tangents share an endpoint, then they have to be the same distance. Okay, all right, so now we have that covered. Now let's go here where we have UC. So U is a point that is shared, that's shared with BU, that segment, and UC. Okay. Well, UC is X, so that means that UB, which is sharing the endpoint, is also going to be X. Okay, so that's going to be X. It's the same. And then finally, we come back over here to, or we come here to B, or go to T, I should say, and notice that T again is an endpoint that's shared with this segment TB, which is a tangent, and with TA. And since TA is X, that means that T to B has to also be X. Okay. So now we have more information on this picture. So obviously at this point, we need to find the value of X. So here's what we're going to do. We're just going to just take all the parts of that quadrilateral that's on the outside, and we're going to add them up. So let's see here. Right now we have 1, 2, 3, 4 X's. So I'm going to have 4X. So let me get that here for you. Yes. Okay. So basically we have, well, actually, let me do it this way. We have X plus X plus X plus X. So see, X plus X plus X plus X. Then you have plus 3, then another plus 3, then another plus 3, and then another plus 3. And that's going to equal to the perimeter, which is 18 units. So it's X, so that's what we got. So now all we have to do is we just need to combine like terms. So we have the 4 X's right here. So we have X, 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 which is going to be, like I said, it's going to be 4X. So we have 4X. And then we have the 4 3s. So 3 plus 3 plus 3 plus 3 is going to be 12. So 4X plus 12 is going to equal to 18. So 4X plus 12 is 18. And so now it's just a matter of you solving for X. It's a two-step equation. So we're going to subtract the 12 on each side. So it's going to be 18 minus 12, which is going to be 6. We bring down, or we're going to cancel this out, and we're going to bring down 4X. And then we're just going to divide both sides by 4. So divide both sides by 4. And that's going to be X equals 6 divided by 4. And just for kicks, we're just going to go use our calculator. And here's our calculator. And so all we'll do is just do 6 divided by 4, just like that on Desmos, and I get 1.5. And I'm okay with the decimal if you on this particular case. So that's the value of X. So we're just going to come back over here, and we're going to write that X is indeed 1.5. And that's all I need to find in this problem. So again, it's about the rule that if a if two tangents share the same endpoint, okay, two tangents share the same endpoint, then they must be congruent to each other. So we just worked our way around this quadrilateral to come up with the values that we needed. And we were able to write this equation out and then be able to solve for x. Okay? All right? And there you go. All right. So thank you for watching this. Again, I hope that this helps you do problems that are related to this. And of course, I also look forward to seeing any notes that you do from this video. So thank you for watching this one. I look forward to seeing your work and have a good one. And we'll see you the next time.